Hi, welcome back to another episode of looking at old, obsolete tool room milling machine accessories. Today we have the 40 taper high-speed head of my FP1 mill. This is a 1200 to 6000 RPM high-speed head with belt drive and a separate motor, and I had briefly shown it in an older episode of a shop talk already, but I haven't used it since then because it needs some work. I definitely need to take it apart and have a look at the bearings, clean them and lubricate them, because the bearings on all the Deckel milling heads and milling spindles are extremely expensive to replace, and you better take care of them. So let's get this off this little trolley I built and have a look. Got it on the bench with some wood blocking so the spindle nose doesn't hit the table. This is a really awkward piece to handle. It's super heavy, super cumbersome, and very, very top heavy. So first thing to do is to get the motor off to make it a little bit less top heavy when we handle it. So there's a lock here, so the motor can slide back and forth. And we can undo the belt this way. This takes off the belt tension. And there are two screws on the back side and a gib, or more of a clamp, a spring-loaded clamp. The springs are so the clamp gets pushed off when you loosen the screws. Nice touch. And then you can just yoink the motor off the head. We'll deal with the motor later. It might need new bearings. We definitely need a new belt. This one has seen better days. Also, we need to pull the pulley off. I will bring the camera around. Let's see how the pulley of this thing comes off. In reality, I just need to look into the drawings, but it's more fun to figure it out on the go. As long as there are no major hiccups that require hammering or a gear puller, it's just nice to look and stuff and figure it out as you go. So there is a set screw. This comes out, and I suspect that the pulley is frozen in place on the drive shaft here. That's usually the case. Two things: we could either heat it up a little bit. Aluminium expands 3 times more per degree temperature change than steel, so heating it up will make it very, very loose on the shaft. Or we take a gear puller and just pull it off. But I don't like that option because on pulleys you often get into the danger of cracking these thin walls of the pulley. I think I'm burning some rat poop. There we go. It's often just, yeah, this is like 40 degrees Celsius now. It doesn't need much in many cases to make stuff go apart. No need to hammer on spindle bearings usually. If you're working on machines or equipment that's half decently designed and built, it most of the time comes apart effortless. This casting This is an aluminum casting here. This comes off too, if I remember correctly. There's a clamping screw down here. But I think this needs to come off too. The interesting part will be the quill. But I think the bearings that are in there for the belt drive also need replacement. They didn't sound too great. Okay, here we go. This plate comes off. Oh yeah, this needs to come off. This is just a piece of, this is a casting. And now this comes off. And it's already much more manageable and not as stupid top heavy anymore as it used to be before. So this up here is the drawbar, by the way. And it's sturdy. To make it even more manageable, we will take off the head from this arm. It's two screws, and this also allows the head to tilt up to 90 degrees. Old mechanics trick. Wrench goes over a Allen key as an extension. So, and this, ugh, okay. And this usually should allow the head to rotate if it wasn't gunked in place. Oh, by the way, if you do something like this, use wood blocking. That's a little bit more sensible than 4 pieces. Well, just it. Okay, it's already separating. I'm just using the wooden handle of the hammer against the casting, not against the spindle. There it goes. Okay, it starts to move. I'm adding a little bit of WD-40 equivalent. This is just petroleum with a little bit of whey oil mixed to loosen up the gunk on the intersection of these two parts. The backstory of this head is I bought it from a former apprentice master, and when he retired he took this head from the apprentice shop with him. Okay, there we go. Okay, now we're down to now we're down to manageable parts that don't require a lift or a crane. We set that aside, we set my firewood aside. We'll find a box for the parts and we will deal with the head. That's the most important. Let's get a disassembly rack here. This is the back side of the head, and here we can see the quill with the gear teeth for the rack and pinion motion, and as you can see it's moving freely. And this is also where we get our generous 60 millimeters of travel on the Deckel milling machines. This is similar design as on the normal geared vertical head. And now it's going to be funny. So let's remove the lock here. Deckel has a funny construction here. The clamp on these heads is a split clamp. You have one screw here that's actually clamping it, but it's split over here too. so you can remove it completely. We have one tapered ring that's loose and a dovetail section on the underside of the head. And those two together form this prismatic shape. And when you tighten this split ring, which has the same prismatic shape as these two rings combined, you clamp the quill. You basically clamp this loose ring to the quill and then both together. This is a fairly non-influencing way of clamping the quill. That's the same design as on the regular milling head. I'm stop saying that because all of these heads are the same. So did I mention that it's a 40 taper spindle? Yes, it's 40 taper, so it takes the same large tooling as the rest of the machine. Now it would be nice if we could get the quill out of there. So this is the upper end of the spindle, and the drawbar on these machines is captive. You can't just pull it out. They are pinned in place with this captive ring. That's a nice design feature because that way it pushes the tool out of the spindle when you unwind the drawbar. So let's see if we can get the tapered pin out without much drama. I checked the drawing, it is a tapered pin. And it should come out with a little bit of precision. There we go. Note that I supported the drawbar here, so that I don't put any hammering forces into the bearings. So, and then you can just unwind the captive ring up here. This is threaded on and then pinned in place. And the drawbar comes out the front. Stefan, that's a funny looking drawbar. Yes, that's because Deckel used an external thread on the tools, S20x2 buttress thread. As you can see on this hydraulic tool holder here, the thread here is buttress thread and it's external. These are standard 40 taper tool holders, which you would also put in a CNC mill, but you can buy the S20x2 pull stud and transform it into Deckel compatible tooling. And this threads on into the drawbar. Often asked question is, Deckel doesn't have drive dogs on the spindle. Yes, because Mr. Deckel was of the opinion for light tooling, light duty tooling, you don't need the drive dogs. Light duty tooling means things like a 30mm end mill in a direct clamping collet. No drive dogs, not a problem. Never ever had one of these slip in a Deckel spindle. You have to be really, really aggressive to create any problems here. For very large shell mills, wheel cutters, form cutters, you would put in a drive ring. That's a ring with drive dogs that engage the slots of the spindle and also engage the slots in the tool holder. But in the 20 years I'm doing this, I used it maybe once or twice, usually for very large slitting saws. The very large slitting saw being in the range of 300mm diameter. Okay, let's see how we get the quill out there. I wonder if this will explode in my face when I pull it off. There is the coil spring, the quill return spring in there, so I have to be a little bit careful here. I checked the manual. According to the document, You remove the screw that I just undid, and then you push the pinion shaft through to the other side, and you hold this part and slowly unwind it by hand. Doesn't sound too hard. I don't want to hit the end of the shaft with the hammer directly, so I'm just putting a threaded stud in there, and I'm going to hit on that very, very, very lightly. Oh yeah, this really doesn't need much force. Doink. Okay. Now I can let the spring unwind. Okay. And let's get the stud out here. Dunk. Okay, this comes off. So this, yeah, I'm leaving the spring housing together for now. Not adventurous enough to take this apart right now. Now we can pull this is the pinion shaft. This drives the quill. And now we should be able to pull the entire quill out of the casting. There we go. Okay. Not much left. Now we come to the exciting part, taking apart the quill itself. Let's create a cleanish work surface before we tear into the spindle. This is not a clean room by far, but let's make it better. Let's do it as good as we can. First we have a felt ring up here. We better don't destroy this, because otherwise I have to make a new one. This looks still pretty nice. And we have a lock nut up here. This needs to come off. As far as I understand, these spindles are fairly simple designed. In an ideal world, this shouldn't require a ton of force. Clamped it in a vise with leather glove as a protector. There we go. Okay, this is surprisingly tight. There we go. Okay, let's see. Yeah, that's why I do this over a plastic tub, so you don't lose 575 ball bearing balls. Do as I say, not do as I show. Okay, there's a lot of balls. There is the front ball cage. We have to clean them and inspect them. And there's the rear ball cage with the balls. Okay, this looks all very, very doable. It's not rocket science. It's spindle science. Okay, let's count them. 2, 4, 6, 8, 10, 12, 14, 16. So okay, got all of them. 16 per ball cage. So this is the rear bearing and this is the front bearing. Keeping them separate just so I don't mix them up. It appears to be in brilliant condition. The funny thing is, this arrangement in here is an angular contact bearing setup, but it doesn't have an inner or outer race and as a separate ring. The bearing race is directly ground onto the spindle and into the quill housing. In the back, the outer race is also ground into the housing, and the outer race is ground on the separate ring, so you can adjust the end play and assemble it, of course. This doesn't look too bad. It's just dirty. And I think I should do the main spindle of my machine too. Doesn't hurt, because Deckel stated in the manual to take the spindles apart every 5,000 hours, clean them and re-lubricate them. And I'm not sure when the last time was when that was done to the geared head of my spindle or of my mill. And the harsh reality of these machines is nobody ever did this until they had a problem. Nobody took these heads apart every 5,000 hours and greased them and cleaned them. You're supposed to clean them with clean gasoline, then re-lubricate with a special Kluber grease, not NBU 15. Okay, let's bag and tag these parts. So this is the front bearing cage and the balls, otherwise known as vorderes Spindellager, forward-facing spindle bearing. So this spindle is rather nice because it is adjustable very easily. You just tighten the nut and it gets tighter. This is on the needle bearing head that I have on the machine. You have to change the needles. You use larger diameter needles to decrease the side-to-side play. The end play can be adjusted with a nut. This is hinteres Spindellager, also known as rear-facing spindle bearing. That's nice. Okay, I'm a little bit relieved that it's looking that good. I will clean everything. That's a lot of petroleum, WD-40, whatever. I mentioned that I found something in the casting. One was a clay pebble, one of those blown clay pebbles that you use to plant, that you use for plants. And the other one, a little bit more grim, is a bone. That's the first one for me. I have found all kinds of stuff in used machines and equipment, but a bone is new to me. And when I opened the machine, when I took off the pulley with the torch, I made the joke that I'm burning quite a bit of rat poop there, and well, that joke backfired. When we look in there in the casting, there is a pile of stuff in the corner back there. There are brown remnants, that's probably rust, but also small black pebbles. Let's zoom in a little bit, get this in focus. And part of it is, with very high certainty, rat or mouse poop. So I suspect a mouse or a rat got into the casting from the underside, dragged in, had a bone to pick on the inside, and also dragged the clay pebble in there for whatever reason. and left it in there. Definitely have to clean out the casting. I don't want the rat poo in here. First of all, it's gross, and second of all, it's a health issue. The Highspeed head was sitting outside, semi-outside in a open-walled barn, kind of like a pole barn, and well, I suspect a critter found its way in there. Not terrible, can't clean that out. Here are all the parts laid out. The quill is here. And we have the spindle wrapped in tin foil here. This is just so they don't collect dust and debris over time while I'm working on other things until I get back to this. The aluminum foil keeps everything cleanish. I took apart the bearing assembly for the pulley too, which consists of two large deep groove radial bearings. And I'll zoom in. Somebody at Deckel who assembled this had a really bad day. So there are two bearings here and here, separated with a spacer ring, and there are also some Belleville washers to preload the bearings for the belt drive. Here is a key that's riveted in. That's providing the torque transfer from the pulley to the quill and allowing the axial movement when you use the quill for drilling. But what you might notice is this little area here. Somebody at assembly got the bearing on either a tiny bit crooked, or there was a little bit of burr or a little bit of debris, and when he pressed on the bearing, he literally pulled a chip off the material and raised material down here. So he take a nice cut with the bearing and left with this ugly portion down here. This is not a big deal for me. I'm just going to remove this burr and just stone over it. But goes to show even in decent quality manufacturing, stuff goes wrong all the time. And interestingly enough, the spindle has two keyways, 1, 2, but the drive has only one key. So the spindle is not a real spline drive, it's just driven via a single key. Also, only one of the key slots here is finished. I suspect this is for balance reason and maybe to prevent warping during heat treat. So if you have a keyway on one side and then you heat treat the spindle, it might banana on you. If you put a keyway on both sides, it might stay straighter. And while we're here, let's have a look. Let's wipe this down with a Kim wipe. This highly polished area here, this is where the bearing balls run on the spindle. Directly on the spindle there is no extra bearing ring. The rear inner ring of the spindle, or bearing race of the spindle, is provided by this ring. This is a separate piece, of course, because the spindle has to be adjustable. So this ring sits on here. A very tight sliding fit. I'm not going to push it on completely, but you can see that you have the polished and finely ground bearing race back here. And this creates the second inner race of the angular contact ball arrangement of the spindle. On assembly, this is pushed on and adjusted with the lock nut right here. And that's the reason why I say that the Deckel spindles are rather expensive to rebuild, because once these races are damaged, you have to send the spindle out for grinding. There is not much you can do about it yourself if you don't have a cylindrical grinder or a surface grinder with a very large spin fixture. So same deal here, a quill, piece of hardened steel, extremely well finished on the OD. On the inside you can see again the sprite band around here. This is the outer race of the bearing, and on the other side we have the same thing up here. This is the race for the bearing again. Why did Deckel choose such a horrendous complicated bearing arrangement? I mean, making this housing here is really a complicated affair. It's hardened, it's ground very finely on the OD, it has a rack ground into it, and on top of all of it, it has two bearing races ground into it. Well, as far as I understand it, both on these and the needle bearing spindles, they did it to keep the diameter and the size of the spindles as small as possible while providing a very rigid spindle. Just to put it into perspective, you're saving all the diameter that a separate inner and outer ring on a bearing would require that you can put just into the material of the quill. As you can see, the quill is not much larger than the major diameter of a 40 taper tool holder, and still it's a very well built spindle. So that's, as far as I understand, the reason why Deckel has chosen this rather elaborate way of building spindles. Over here, I cleaned this large casting. I took it outside and I flushed it out with a hose. I did want to get rid of the rat poop. Then I dried it with a heat gun and sprayed the entire inside with LPS3 and let it dry, so I don't have any corrosion issues anymore. The rat poop is very corrosive and caused trouble here on the flange. I cleaned that up already, scraping it off with a razor blade and final cleaning it with Scotch-Brite and a stone. And now it's nice and clean again. Again, tin foil to keep it free of debris while I'm not working on it. I haven't cleaned this one completely yet, but I wanted to show you something about the bore in here. I think this illustrates it very well with the harsh light of a LED light. There is a crosshatch pattern in the bore. This tells me that the bore for the quill has been honed. So they would put this on probably a jig borer or a horizontal borer. Bore the single point bore the quill, the hole for the quill. After single point boring the quill hole or bore, they would go onto a sun and hone or something like that, like an engine rebuilder would have, and they would hone the bore to a very precise fit. Honing gives a rounder hole than boring in most cases, and also you get this crosshatch pattern, so it catches a little bit of oil and aids in lubrication of the quill movement. I thought that's neat, and being able to still see the pattern from honing tells me that this head was not used very much. The backside, the flange here, this is just surface ground. I will get back to you once I have the replacement parts and when I have a little bit time to put it back together. Also, I think the motor needs new bearings. I haven't touched the motor yet at all. Along with the vertical head, I of course have some paperwork to look at. This is from the sales brochure of the FP1. There is die schnell laufende Senkrechtfräskopf, which means fast running vertical milling head or high-speed head, 1900 to 6000 RPM in 6 combination of speeds. The one shown here is not the one that I have, not exactly the same. It has a different way of adjusting the belt tension. The clamp for the quill is different. As you can see, the casting is split here and just pulled together with a screw. On the later versions, like the one I have, or the versions that belong to the Deckel FP2 milling machine, we have the ring on the lower end of the head's casting. And it's depicted with a single fluid cutter in the spindle, which was indeed one of the main uses for these. So I think there's not too much in the sales brochure about this head. Here is the technical data, which doesn't 100% match mine, but it's 42 kilograms, 0.55 kilowatt motor, 60 millimeter travel on the quill, and a 40 taper. So, and now technical bulletins. This will be fun. Yeah, we have. So one application was to mill out sharp internal corners with D-bits, with a V-shaped D-bit to go down the vertical wall of an internal shape to create a sharp corner. And you had to rotate the work for it, and you had to angle the mill head for it. I think I will show that at some point because it might be interesting. You don't need this these days. Today you just ram EDM, wire EDM, or 5-axis mill, something like sharp internal corners. But back then this was an option. Here is something rare. This is the 2-axis high-speed head on a FP4. This thing here is the same as mine, but you have this double elbow piece here, and then it interfaces differently to the machine, but the general idea is the same. And as you can see, it's swiveled in 2 directions, and they are also picking out an internal corner on this die shoe or whatever this is with a D-bit. The FP4 was a real beast of a machine. So if this guy isn't the smallest lad in the marketing department, you might get an idea how big an FP4 is. Here's a little bit more about using the double swivel head or the swiveling head and the workpiece at an angle or the workpiece oriented at 2 angles to pick out corners and drill angled holes. So this is fairly complex problem solving here. This is compound angle work. This can really mess with your head. As you can see here, you have the nod and the tilt. Like on a Bridgeport milling machine, you can do pretty much the same on a Bridgeport with the tilt and the nod. Probably terrible to adjust, just due to the sheer weight of a Bridgeport head. Okay, that's all I got for the high-speed head. So that's all I got about the high-speed head and some general rumbling about the technical bulletins and the sales brochure. I have to wait for replacement parts, belt, bearings. I will get back to you when we put the high-speed head back together. So thank you all for watching, and I'll be back.